Welcome back, Math 30-2. Today we are combining what we learned in the first 4 lessons into this lesson. We are combining all the laws of logarithms that we've learned to solve problems. So if you're having problems with the first few lessons, you might find this one a little bit more tricky. But it will also, on the positive note, reinforce what you learned before so you don't forget it. So here are our 3 laws that we looked at so far. We have the product law, the quotient law, and the power law. And our first question says, we want to solve this, and we have 3 different students to solve it in different ways. Well, we look here at Shane, and he wrote it out, and the first thing he did, I look at it, and he says, well, this is log x2, we have 4 log x2s, and log x8. Those aren't the same number. So he's going to make them the same number so he could solve them. So what he did was, he knew that 8 is equal to 2 to the power of 3. That's how he has that right there. Okay, so that's what he did there. Next, now he looked and he said, well, I could put this 3 in front. Okay, so he puts the 3 in front. Now he looks and he says, well, I have 4 of base x log 2's, subtract 3 of base x log 2's, which leaves me with only 1 base x log 2. Okay, so that seems pretty good so far. Let's look at Emma's work. Okay. So Emma's work goes, she has this, and she puts this 4 to the exponent, right? Now, this is so far correct. She could move this 4 into the exponent. I see what she's doing here. She says it's subtraction. When we subtract, that means division, normally. So now she has them, so it's log 16, because 2 to the power of 4 is 16, minus log 8. But now, what happens if we're subtracting? That means division. So we have to go 16 divided by 8, which is log x2. She has log x8, base x log 8. Logarithm 8. Or logarithm 8 base x. That's not right, so this is wrong. Let's look at Clayton's work. Here he's looking at the same thing. But what does he do wrong here? He puts this and he multiplies this into 2. Well, this 4 should be on top, so his mistake is just in the first step to get this, so his is wrong automatically as well. So which one is right? Shane's work is right. As we see though, there are many ways, there's 2 ways of solving this. We could have gone about it a different way and still get the right answer. After this, if you divide, it is log 2, if you did it right. 16 over 8 is log 2. So that could be right as well. So here we go. We're now going to use this example here. We're going to try and solve this one and simplify it the best we can. Make it into a simple logarithm. So I have 1/2 log 68, or 1/2 of base a log 16. Okay, so I'm first going to put that 1/2 in there. And now we're subtracting. So that was the first thing I did, was I removed my exponent, or I removed my numbers in front, and I put them to my exponent. So I removed my coefficients. Next part here are my constant terms. Next part here is, well, what is this? Log a square root of 16 is 4. Subtract log a, the cubed root of 8 is 2. This looks complicated. Well, subtraction means we just divide those, right? What is 4 divided by 2? 2. That's how we get that one. That's it. Okay? Let's try this next one here. So we have a log e, log a. Oh, this looks complicated. Well, let's first put everything so there's no coefficients in front. So I'm going to have log a minus log the logarithm of e to the power of 5, subtract, let's get this going here, subtract log a squared. Okay, so whenever I'm doing this simplifying, I normally don't like numbers in front. I'm just going to put them on top, how I do it. Here he put them on top because he's adding, subtracting, and these are the same. And since those are the same, he can add or subtract. But here I notice I have that e. It's going to be impossible for me to make this e like those a's. So it's going to be hard for me to add or subtract. Okay? So now I'm going to look at this here. I'm going to combine all my like terms. So here we go. This is dividing. So I have log a, and we divide by e to the 5. But this subtraction also means we divide by a squared. So I'm going to continue this. Well, a divided by a squared leaves me with just an a on the bottom. So my answer is log 1 over e to the 5a. That's it. Or I could even say negative log e to the 5a. You could do that, because that will just flip this. If I put this to the negative 1, well, isn't that the same thing as that? If I put all that to the negative 1, it flips it. So that's all I did. Okay? Here we're going to go. Now we're going to look at class example 3. We have this plus that. Okay, so there's our two logarithms. We want to write as a single logarithm, and then it says you have to evaluate. So we're going to evaluate the best we can. So first of all, I look at this. They're both in base 6, but are they the same? They are not the same, so it's going to be very difficult for me to simplify them. Okay, so I'm going to have log 6 to the power 4 squared, because I can't just add these together, because these aren't the same thing. And then we're going to go plus log 6 2.25. All right. Now this is going to give me log 6 16. And we have plus. Now when we add, that means we are going to multiply. It's the product rule. So I'm going to go 16 multiplied by 2.25. Okay? So that's going to give me a total of 3236. Which is equal to 2. Right? 6 to the power of what is equal to 36? 2. There we go. And look at that. We just did all of our lessons in one question. So it's a good review this year right now. Now the next one is saying log 5, and if we're looking at the logarithm in base 5, p, so base 5 logarithm of p is always equal to 12. Okay? And it says, determine the exact value of each. Well, here we know this is equal to 12. So that's just 5 multiplied by 12. Okay? So that's going to be the same as 60. Now this one here is just a little bit more complicated. We have the 5 on the inside. How do I deal with that? Well, that's the same thing as, this means multiplication. Remember, we have two things multiplied together. So I'm going to separate them. That's 5 multiplied by p. To separate them, that's log 5 plus log p. And it's still base 5. Well, I know this, 5 to the power of what is equal to 5? 1 plus 5, and this part here is always equal to 12. So I'm going to get 13. Oh, that's interesting. Now here we're taking a look at our next one, same idea. This is saying 25 multiplied by p3. So I'm going to separate these into two different entities. So I'm going to have log 25 plus log. Okay. Now this 3 could go down in front because of our power rule, right? So we're going to be left with, and this here is just okay. So 5 to the power of what is 25? That's 2. And we know this is equal to 12. Multiplied by 3 is equal to 36. So that's going to give me 38 is my answer. Okay? Now our very last question says, if log 2, if we're in base 2 logarithm, x is equal to a, use the law of logs to show that this is equivalent to that. Alright, so we want to show that this here is equivalent to this. Alright, so I'm going to first write this out. Log 2, 32, x squared is equal to 5 plus 2a. Well, first thing we're going to do is separate this. I have a multiplication there, so I'm going to separate. And it's in base 2. Now, I could put this 2 down in front. This is all equal to 5 plus 2a. And this here, 2 to the power what, is 32? That's 5. And I put this down in front, and we said log 2x is equal to a. And so we have to go 2 multiplied by that is 2a. And there we go. That's how we solve that. Well, I hope you enjoyed the video, and I hope you understand it all. And I'll see you tomorrow. Hopefully you have some good questions for me as we work on the assignment together.